Hey guys, welcome to ANS Solver. Today we'll be doing the concept of chain rule, okay, which is a subtopic in the chapter of differentiation. Okay, so this concept is really important because it's applied everywhere. Okay, there's one basic formula which you need to know. Okay, and then we'll do a lot of examples so that you're 100% sure of how to, apply the concept of chain rule. Okay, so let's say if I have something like f of g of x. This is the function which I have, and I'm asked to differentiate something like this. Okay, the differentiation for something like this is first the differentiation of f, which is the outer function. So I'll get f dash, which will be multiplied by the normal function, which is g of x. Okay, first only the outer function will be differentiated. Okay, and the inner function will be written as it is, and this will be multiplied to the differentiation of the inner function, which is basically g dash of x. Correct? This is what I'll basically get. Okay, this is the formula which you need to know. It's a very basic formula, but now we'll do some examples so that we are sure how to implement this formula. So let's say, okay, I have a question which is sine square x. What is the dy by dx of sine square x? Okay, the first thing you need to do is imagine brackets. I know sine square x is basically sine x the whole square. Correct? This is what I have. First, differentiate the outer bracket. Okay, so treat sine x like a variable. Okay, so when you differentiate, let's say my sine x is, let's say, a. How do you differentiate a square? You write it as 2a. So the dy by dx first will be 2 sine x, correct, raised to 2 minus 1, which is 1, multiplied by the differentiation of the inner bracket. The inner bracket is a differentiation of sine x, correct, which is simply cos x. So you can simply write this as 2 sine x cos x. Correct? This is what I'll basically get as my answer. Okay, it's okay if you didn't understand it. Let's do another example. Let's say I have something like cos square x. So first I can write this as cos x the whole square. Then my dy by dx will basically be equal to the outer bracket first. So first I get the 2 down. Okay, I treat cos x like a variable. So I write this as 2 cos x, correct, raised to 2 minus 1, which is 1, multiplied by the differentiation of cos x, which is minus sin x. So I can simply write this as minus 2 cos x sin x. Correct? This is what I basically get. Okay, now we can do more examples. Let's say if I get something like sine 2x. Okay, what is the dy by dx or something like this? The first rule is put the brackets, correct, put the bracket first so that you know what's outer, what's inner. Now you differentiate the outer function. So the differentiation of sine is cos. So I write this as cos, and the inner function as it is. So I get cos 2x, but this will be multiplied by the differentiation of the inner function, correct, which is the differentiation of 2x, which is 2. Correct? This is what I basically get. So my final answer, which I get, is 2 cos 2x. Correct? This is what I basically get. Now, let's do another example. If I have something like cos 2x. So first, okay, you can pause the video and try this. So first the outer function, which is the differentiation of cos. What is the differentiation of cos? Simply minus sign. So I write minus sign into 2x. 2x is the inner function. So I write it as it is, multiplied by the differentiation of 2x, which is 2. So I get my answer basically as minus 2 sine 2x. Correct? Now let's do variations of this example. Let's say you get, okay, you're asked what is the differentiation of sine square 2x. Okay, something like this. So first you need to know that you can write this as sine of 2x, correct, the whole square. First write the brackets properly. Okay, now we need the dy by dx or something like this. So we'll go bracket by bracket. First let's see the outer bracket where I have 2 here, correct. So what's the differentiation of 2? Correct. So it's basically a variable square. So I can write this as 2 multiplied by the inner function, which is sine 2x raised to 1, multiplied by, go to the next bracket where you will get the differentiation of sine. The differentiation of sine is cos. So I write cos, but 2x will remain the same, as that's the inner bracket of sine. Now you will multiply this to the most inner bracket, which is 2x. The differentiation of 2x is 2. Correct? So first the outer bracket here, correct, where I got this. Then you go inside where I get sine 2x, then 2x. This is how you differentiate. So it's basically a chain, correct. So I can simply write this as 2 into 2 here, which is 4, and I have sine 2x multiplied by cos 2x. Correct? This is what I basically get. So now what I can do is I can do more examples. Let's say I get something like cos raised to 4 6x. Okay, looks quite complicated, but let's go step by step. First, have your brackets clear. You can write this as cos 6x, correct, the whole raised to 4. I can write it like this. Now I have my dy by dx. First the dy by dx of the outer bracket here, where I have the 4. So it's basically a variable raised to 4. So I can write this as 4 multiplied by the inner function as it is, correct, raised to 4 minus 1, which is 3, multiplied by, go to the next, bracket, which is basically cos 6x. So first differentiate cos. What is the differentiation of cos? Simply minus sign. So I can write this as minus sign, and I'll write the inner bracket, inner function as it is, multiplied by the differentiation of the inner bracket here, which is the differentiation of 6x, which is 6. Correct? So now I can write everything together. So first I can do 4 into 6, which is 24. Correct? With, I can write this as cos cube 6x. Correct? You can simply write a negative here and a sine 6x. Correct? This is how you can simply write something like this. Okay, so this was basically some of the basic, chain rule which you need to know. Okay, we'll do much more examples right now. Okay, so that you're 100% sure, because this is a very important concept. We'll do other rules like product rules, quotient rules, implicit differentiation. This will be applied there also. Okay, so let's say I have something like tan square x. What is the differentiation of something like this? First, you can write this as tan x the whole square. Now, I have my dy by dx. Correct? The differentiation of tan x the whole square. First, I have the 2 here. Correct? So, I differentiate the 2, the outer bracket. So, I get 2 tan x the whole raised to 1 multiplied by the differentiation of the inner function, which is the differentiation of tan x. The differentiation of tan x is sec square x. Correct? So I can simply write this as 2 tan x sec square x. Correct? Now I have, okay, let's say if I have something like tan raised to 4, okay, 2x. If I have something like this, how do I differentiate this? First, convert this into the proper form, which is tan 2x, correct, the whole raised to 4. Correct? This is what I get. So for the outer bracket first, so I'll write dy by dx. So the outer bracket, so first I write this as 4 tan 2x, the inner function as it is, raised to 4 minus 1, which is 3, multiplied by the differentiation of the inner function. So the inner function first is tan. So the differentiation of tan is sec square. So I write this as sec square 2x multiplied by the differentiation of the innermost function, which is the differentiation of 2x, which is 2. Correct? So now I can multiply this. First I can do 4 into 2, which is 8. And I can write this as tan cube 2x, okay, multiplied by sec square 2x. Correct? This is what I basically get. Okay. So basically these were some of the examples, but this was chain rule mainly applied, okay, to the trigo identities, okay, the trigonometry, tan, sine, okay. So now let's do, the logarithm and the exponential, okay, chain rule. So let's say if I have something like e raised to 5x, how should I differentiate something like this? Okay, first write this as e with the bracket, okay, 5x, okay, e raised to the bracket of 5x. So the dy by dx will basically be, the differentiation of e is the same. So you write the same function as it is, which is e raised to 5x, correct? But this will be multiplied by the differentiation of 5x. The differentiation of 5x is 5. So you can simply write this as 5 e raised to 5x. Correct? Let's say if I get something like e raised to minus 4x. So first you can write this as e raised to minus 4x with the bracket. Correct? The dy by dx, okay, will basically be e raised to minus 4x as it is, because the differentiation of e is same, multiplied by the differentiation of minus 4x, which is minus 4. Correct? So I can simply write this as minus 4 e raised to minus 4x. Correct? Now, let's say if I get something like 2 e raised to 3x. So first I can write this as 2 into e raised to bracket 3x. Now the dy by dx, okay, keep the constant, which is 2, out as it is, multiplied by first the differentiation of e, which is the same. So I write this as e raised to 3x multiplied by the differentiation of the bracket, okay, 3x differentiation is 3. So I can simply write this as 2 into 3, which is 6. So I write 6 e raised to 3x. Correct? So these were some examples of the exponents. Okay? So now, let's say if I give you something like ln 2x. How do I differentiate something like this? Okay? So the dy by dx is simple. First, the differentiation of the outer function, the differentiation of ln, okay, is simply 1 over x. So I'll write 1 over divided by whatever I have in the bracket here. So I have 2x, correct? Multiplied by the differentiation of the inner bracket or the inner function, which is the differentiation of 2x, which is simply 2. Correct? So I can simply just write this as 2 over 2x, which is just 1 over x. Correct? So this is a very good thing, okay, which you have noticed. Let's say if I have ln of, constant multiplied by x, okay, the answer you get is always 1 over x. Okay, so this is a very important property you can know. But now, what if you get something like ln cos 2x? Okay, so this is logarithm, okay, with a trigonometric function also. So first, my dy by dx, go bracket by bracket, okay. The differentiation of ln is 1 over x, where x is inside the bracket. So this will be 1 over the function which I have inside the bracket, correct? Multiplied by, now I'll go one bracket inside, the differentiation of cos, which is minus sine. So I can write this as minus sine 2x multiplied by the innermost bracket, which is the differentiation of 2x, which is 2. So I can simply write this as minus 2 sine 2x over cos 2x. Correct? As you can, for further calculation, sine 2x over cos 2x is tan 2x. So you can even write this as minus 2 tan 2x. Correct? So let's do another example. Let's say one last example. If I have ln, okay, of sine raised to 4 6x. Very complicated. So the dy by dx, first, I know before doing the dy by dx, I can write this as ln sine 6x, correct, the whole raised to 4. So now let's go bracket by bracket. First, ln, the differentiation of ln is 1 over x, correct, where x is whatever inside the bracket. So I can write this as 1 over the function, okay, which I have basically inside the bracket, correct, which is basically sine raised to 4 6x, multiplied by the next thing, which is basically the 4, okay, the next bracket. So I basically have 4 with sine 6x raised to 4 minus 1, which is 3, multiplied by now the differentiation of the next bracket, which is the differentiation of sine, which is cos. So I write this as cos 6x multiplied by the differentiation of 6x, the innermost bracket, which is 6. So I can simply just write this as 6, okay, 6 into 4, which is 24, with sine cube 6x divided by, okay, sine raised to 4 6x multiplied by cos 6x. Correct? This is what I'll basically get. correct, going bracket by bracket. Okay, and now finally I can write this as, I know I can cancel simply this and I can cancel this to write this as 24 cos 6x divided by sine 6x, correct, which is the final answer. So this was basically, the formula for chain rule. Okay, sorry, I got cramped up a little bit in the end because I was running out of space. Okay, but yeah, this is the formula which you basically need to remember. Okay, so go over this video all over again. Once you have actually go over this video 2-3 times, solve the sums by pausing the video all over again. Once you get the grip, once you understand the logic, okay, you will be, you can go to the next topics like the product rule, quotient rule, okay, which are the other subtopics. Okay, because this knowing the chain rule is really important. Okay, because it's asked almost in every rule, in the product rule, chain rule, implicit differentiation, okay, which we'll be doing in the later videos. So yeah, please view the next video, which is basically related to the product rule, okay, to complete this chapter. Thank you very much for watching.